All right, this video is going to be going over systems of linear equations with two variables. So systems of equations with two variables means that you have two equations with two different unknowns or two different variables. And a solution of that means that x and y both satisfy this condition. So example, here if I plug in 4 and 7, I end up getting a true statement here. And if I plug in 4 and 7, I get a true statement here as well. So that point is on both of those graphs or solves both of those equations. So we have three different types of solutions that you might have. An independent solution has exactly one pair. So you can see right here in the graph, like these two lines intersect one time. Now an inconsistent system has no solutions, or the two lines are parallel to each other, or we say that there is no solution. Those two lines will never touch, so they don't have that point in common. There's also a dependent system, which means that once you solve it, you find that the lines end up being the exact same. And so we can say that this has infinitely many solutions. All right, so we're going to solve this one example by all three of the methods that you would use, the main methods at least, for systems of equations. So the first is do graphing. I'm going to solve both of these for y. So I'm going to subtract 2x to the right-hand side. I'm going to do that here as well, and then multiply through by a negative. And then I'm going to use Desmos in order to graph these. All right, so I have y equals, let me pull that back up, negative 2x minus 8. And I have y equals, and that one was x plus 1. And you can see right here that that is going to be our solution at negative 3, negative 2. We always write our solution as an ordered pair. However, if you don't have a graphing tool, you might want to use what's called a method of substitution. So it would be easiest, I think, to solve this for y like we did here. And then you can substitute that in to that second equation for y. I'm going to distribute the negative, combine like terms, subtract 8, divide by 3. And you'll see I get the exact same answer here. I'm solving the same system, just in a different method, a different way. And then I can plug that back in to solve for y. And I can plug into either one. I just chose this one since that's the substitution equation that I used. So I get 6 minus 8, which is negative 2, and you can check, and that's what we got here when we graphed as well. All right, the last method is called elimination or addition method. And so in order to do that, I'm going to copy these down here. So 2x plus y equals negative 8. And then what was our other one? X minus y equals negative 1. All right, and this is actually the method of choice I would personally use when I see this, because I have one of my variables, in this case y, where one is positive and one is negative. And so if I literally just combine these two functions, then I get 3x, these cancel, equals -9. So I'm just adding those two functions together. That's why it's called the addition method. And then I see x equals -3. Maybe I now plug into here because that one looks nicer. And then I can find my solution pair using that addition method.